Hello everyone, welcome back to the Token Minds training series. Today we are looking at how blockchain enables event-based conditional protection in trade finance, where smart contract automatically manage risk, settlement, and payouts based on verified real-world events instead of manual claims in post-trade disputes. The focus here is understanding how real-world events can directly control financial outcomes. By connecting verified data to smart contracts, trade protection becomes automatic and dispute-free, while settlement moves from delayed manual processing to predictable near-instant execution. Traditional trade finance instruments like letters of credit, bank guarantees, insurance, escrow, and receivables all rely on the same operational pattern. Funds are promised off-chain, conditions are interpreted manually, and settlement happens only after documents are reviewed and disputes are resolved. So this creates long delays, high operational costs, and uncertainty around when capital is actually released. Blockchain restructures this model by moving protection logic and funds on-chain from the start. Capital is locked upfront in smart contracts. Conditions are encoded as executable rules, and settlement is no longer triggered by documents but by verified events. This allows LC-like payments, guarantees, insurance payouts, escrow releases, and receivable settlement to execute automatically when conditions are met, turning trade finance from a reactive process into a pre-funded deterministic system. So the first benefit is instant settlement certainty because funds are locked on chain before execution begins. Counterparties no longer depend on future promises or manual approval cycles. When conditions are met, settlement happens immediately. The second benefit is clear, non-decisionary outcomes. Smart contracts remove interpretation from trade protection, so every party knows exactly what will happen under delay, disruption, or value scenarios before the trade starts. The third benefit is lower credit and counterparty risk, since collateral, guarantees, or receivables funding is prepositioned. Exposure does not grow while disputes are resolved. And finally, operations become scalable without added costs. The same contract logic can manage thousands of trades simultaneously without increasing staff, paperwork, or reconciliation overhead. So event-based protection follows a fixed execution pipeline. First, commercial protection terms are encoded as on-chain rules. Next, external events are ingested through Oracle infrastructure. Those events are evaluated against predefined thresholds. When conditions are met, settlement executes automatically and irreversibly, ensuring predictable outcomes with no human intervention. Protection logic is written directly into smart contracts as immutable configuration variables. So this includes parameters like maximum delivery delay, wear severity limits, root deviation thresholds, and absolute delivery deadlines. So settlement actions are predefined using enumerated outcomes such as releasing funds to the seller, the buyer, or splitting settlement. Once deployed, these rules cannot be altered, ensuring that no party can renegotiate outcomes after executions begins. Once protection logic is defined, the system requires objective inputs to drive execution. Oracle infrastructure acts as the control interface between real-world events and on-chain contracts. Oracle nodes are configured to pull data from authoritative sources such as port authorities, shipping systems, weather services, and logistic platforms. Its data update is cryptographically signed, timestamped, and submitted from pre-approved Oracle addresses. The smart contract verifies the Oracle identity, validates the data format, and stores the result as immutable state. No manual data entry or interpretation is allowed. This ensures that settlement decisions for LC payments, guarantees, insurance, or escrow releases are driven only by trusted, verifiable inputs, not subjective reporting. So, threat protection depends on multiple types of risk, not a single trigger. The contract evaluates each event class independently using dedicated logic paths. Delivery-related risks are checked against expected timelines and route constraints. Weather risks are evaluated using severity thresholds, port and infrastructure risk, detect closures or operational restrictions. Regulatory risks capture sections or compliance triggering events. So its event class updates its own on-chain state. The states are then combined later to determine whether protection should activate. This design allows the system to reflect real threat complexity while remaining fully deterministic and auditable, ensuring protection activates only when objectively defined and conditions are satisfied. Real trade scenarios require combining conditions, Boolean logic links, multiple event flags using and or operators. So a protection activates only when the correct combination occurs. Time-based enforcement uses blockchain consensus time to detect delivery delays without relying on external oracles. So once delay thresholds are exceeded, the contract transitions into penalty, partial payout, or alternative settlement paths automatically. So smart contracts provide a deterministic execution environment with immutable state and consensus-based finality. Oracle infrastructure ensures data integrity through signed submissions, multi-source aggregation, and replay protection. Tokenized assets such as stablecoins, invoices, or guarantees are locked in escrow and transferred atomically. Institutional custody solutions enforce role-based access, multi-signature approvals, and hardware security compatibility. So Arbol demonstrates this model in production using parametric crop insurance. So whether thresholds are encoded on chain, channeling continuously supplies verified NOAA data. So when conditions cross predefined limits, payouts execute automatically without claims, without inspections or disputes. So this proves that event-based protection can operate reliably using objective data alone. So, event-based conditional protection removes delays and disputes from global trade by replacing manual processes with deterministic execution. As adoption grows, this model becomes a new standard for managing trade risk with faster settlement and lower operational costs. Tokenmine supports organizations by translating commercial risk terms into smart contract logic, designing protection triggers, engineering settlement conditions, and configuring collateral and payout structures. So thank you for watching. You're ready to implement event-based conditional protection that deliver faster settlement, lower risk, and predictable outcomes in trade finance. Reach out to Token Minds. We'd love to help you bring this model into real-world production.